Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, a piece of conventional wisdom from web engineering that is flat out wrong for AI. And following it can blow up your latency tenfold.
Strong open. Set the scene. Why can't one GPU just serve everyone?
Because a single inference replica has a hard ceiling. A serving engine like VLLM packs many requests into the same forward pass. Continuous batching. But that's bounded. The GPU has finite memory for the attention state, the KV cache, and finite compute. Push past that bound and new requests just queue up. Latency climbs.
And that ceiling isn't a setting you can crank up.
No, it's a hardware limit, not a config. So the only answer is to go horizontal. N identical replicas, each a full copy of the model on its own GPU, sitting behind a load balancer. Clients hit one stable endpoint. The balancer fans them out. Standard scaling.
Okay, so far this is just normal web infrastructure. Where does it go wrong?
In how the balancer picks a replica. The default everywhere is round robin. First request to replica 1, next to 2, next to 3, cycle back. And on a normal web backend, that's fine, because requests are roughly equal. Serving a product page takes milliseconds, and one looks like any other.
But LLM requests aren't equal at all.
Wildly unequal. A one-line summary might finish in 20 tokens, half a second. A request for a 3,000-word document generates 4,000 tokens, 80 seconds. That's a 100-to-1 ratio in cost. And round robin is blind to it. It counts requests, it doesn't weigh them.
Oh, I can see the train wreck. It's the supermarket checkout. One cashier gets the cart with 200 items, the next gets someone holding 3, and now a whole line is stuck behind the big shop.
That's it precisely. One replica piles up with monster jobs while another sits idle. Short requests get trapped behind a giant one. Engineers call it head-of-line blocking, and your tail latency, your P99, explodes. With round robin under real LLM traffic, P99 can be 5 to 10 times worse than it needs to be.
So what's the fix? Stick with the checkout. You just look down the lines and join the shortest one.
And that intuition is a real algorithm. Least outstanding requests. The balancer tracks how many in-flight requests each replica is holding right now and sends each new one to whoever has the fewest. Order be damned. The beauty is it self-corrects. The moment a replica finishes its big 4,000 token job, it becomes the least loaded and naturally attracts the next arrival.
That's elegant. The system heals itself without anyone predicting how long a job will take.
Exactly. And that's why the old wisdom, round robin's good enough. Least connections is over-engineering. Just doesn't survive contact with LLMs. Start with least outstanding as your default.
Now I've heard there's a second trick that's specific to language models. Something about reusing work?
Prefix-aware routing, and it's lovely. When a request arrives, the server has to compute attention for every token in the prompt. A 2,000 token system prompt is expensive, but modern servers cache it. If a new request shares the same leading tokens, that work is already done and sitting in GPU memory. The new request skips it entirely.
But that cache lives on one specific GPU, so if the balancer scatters requests with the same system prompt across different replicas,
every replica recomputes the same thing from scratch, and you get zero benefit. So you hash the shared prefix, the system prompt or a conversation ID, and route everything with that hash to the same replica. The cache stays warm there, and every follow-up turn gets a hit. Huge for multi-turn chats.
there has to be a catch. If one system prompt is super popular, that replica becomes a hotspot.
The exact trade-off. So production systems use consistent hashing, or a hybrid, prefer the same replica, but fall back to least outstanding when it's overloaded. You blend cache reuse with load balance.
Last thing. When traffic spikes, you add replicas. What signal tells you to?
And here's the trap that catches everyone. Do not autoscale on CPU. LLM inference is GPU bound. The CPU just shuffles IPSO while the GPU does the real work. So it sits near idle even when you're completely saturated. Watch CPU and your autoscaler never fires. Right when you're drowning. Scale on queue depth instead. It rises before latency does.
And you can't spin a replica up instantly anyway. Loading a 70 billion parameter model takes real time.
30 seconds to several minutes to load the weights into Varam. So autoscaling can't absorb a sudden burst. You keep a warm spare ready. And you only route to a new replica once it passes a readiness check, after the model's fully loaded.
So the one-sentence version?
Don't borrow web defaults for AI serving. Least outstanding over round robin, prefix hash for cache reuse, and scale on the GPU's queue, never the CPU.
Route by load, not by turn. That's the Datarekha audio guide. Catch you in the next one.